The ninth chapter in 10th standard max is polynomials. In some states, the chapter number could be different, but all states who have implemented national education policy will have same syllabus. So even if the chapter number is different, you don't have to worry. The syllabus portion will be same only, and you can check it out from your textbook. Now coming to polynomials. So what are polynomials? Polynomials is nothing but an expression of more than two algebraic terms. For example, 2x plus 5. Now 2x is an algebraic term, 5 is also an algebraic term. When I sum it, I'll get a polynomial. So usually the expression will be a sum. Okay. Now consider another example, 5x square plus 3x plus 7. Here you can see there are three terms, that is 5x and 3x and 7. Now consider another example, 4x cube plus 2x square plus 3x plus 7. Here you can see there are four terms, that is 4x cube is one term, 2x square is another term, 3x is another term, and 7 is another term. So here variable is all x only, not necessary that variable should be x only. The variable can be anything, it can be y, it can be z, it can be v, or it can be u also. For the sake of simplicity, I am giving you very simple examples. Now consider another example, 3x plus 6. Here another example I will give, 6x square plus 2x plus 1. Here 2x cube plus 7x square plus 6x plus 5. Now 5x plus 1, 7x square plus 6x plus 7, 6x cube plus 5x square plus 2x plus 1. So in all these are examples of polynomials. Now here you can make one observation, that in all these three polynomials there is one thing that is common. So the common thing is that the highest power of x is 1. For example, 2x plus 5, the power of x is 1 only. 2x means it is 2x to the power of 1. In the second example, 3x plus 6, 3x means it is 3x to the power of 1 plus 6. Similarly, in the third case, 5x plus 1, 5x means 5x to the power of 1. So the highest power of x is 1. So we say the degree of the polynomial here in the above example is 1. Okay. So whenever the degree is equal to 1, we call those polynomials as linear polynomials. And the general form of linear polynomials is ax plus b. So highest power of x is 1. Ax means it is ax to the power of 1. So here a and b are real numbers and a cannot be 0. Okay. So a, b are real numbers and a not equal to 0 is the condition. And coming to the second category of examples, you can see the highest power of x is 2. 5x square plus 3x plus 7. So highest power of x is 2. In the second example also, the highest power of x is 2. 6x square plus 2x plus 1. 6x square, the power of x is 2. In the third case, here also the highest power of x is 2. So we say the degree of these polynomials is equal to 2. So whenever the degree is equal to 2, we call those polynomials as quadratic polynomials. And the general form of quadratic polynomials are like this: y is equal to ax square plus bx plus c. Here A, B and C are real numbers. A, B, C are real numbers and A cannot be 0 is the condition. And in the third category of polynomials, you can make observation that the highest power of x is 3. So we say the degree of the given polynomials is 3. Okay, so whenever the degree is equal to 3, we call those polynomials as cubic polynomials. And the general form of cubic polynomials is given by this one: ax cube plus bx square plus cx plus d. So here also a, b, c and d are real numbers and a cannot be 0. A, b, c, d are real numbers and a cannot be 0. Now coming to linear polynomials, if we plot linear polynomials in an xy plane, how it's going to be? So if you plot linear polynomials, actually we will get a straight line like this, or the straight line may be like this also, or the straight line may be like this. So you can see in these three lines, one line is meeting here somewhere on the x-axis. The first and second line also, if we extend on either side, it will meet the x-axis. So this line also, if I extend, it's going to meet the x-axis. So whenever the linear polynomial meets x-axis, the y coordinate is equal to 0. So if I take y is equal to 0, so 0 is equal to ax plus b. If I solve for x is equal to minus b by a, I will get. So this is the coordinate of x, where the linear polynomial will intersect x-axis. So the linear polynomial will intersect at point minus b by a, comma 0. So this is that point. Okay, at point minus b comma a, minus b by a comma 0, the linear polynomial will meet x-axis, will intersect x-axis. Now coming to quadratic polynomials, if we plot quadratic polynomials on a xy plane, we get curves like this, and these curves are called parabolas. Okay, so when we plot, we make it like this. See here, in these two cases, the given quadratic polynomial is not intersecting or touching x-axis. Sometimes the given quadratic polynomial may touch x-axis at only one point, like this. Sometimes the given polynomial may intersect x-axis at 2 points. So at the most, quadratic polynomials will intersect x-axis at 2 points only, not beyond that. And we say that if it is intersecting at 2 points, we say the number of zeros are equal to 2. If it intersects at only 1 point, the number of zero of that equation, that polynomial is 1. Now how do you think the cubic polynomials will look when we plot it on a graph, when we plot it on a xy plane? So when we plot it on a xy plane, the cubic polynomial may intersect x-axis at 3 points, like this it may intersect. Okay, it's not compulsory that it should intersect at 3 points. Sometimes the cubic polynomial may be like this and intersecting x-axis at only 1 point. Sometimes it may intersect at 2 points also. So at the most, the cubic polynomials will intersect x-axis at 3 points. and if it intersect at 3 points, we say the number of zeros of that cubic polynomial is 3. If it intersect at 2 points, we say the number of zeros of the cubic polynomial is 2, and if it intersect at 1 point, we say the number of zero is 1. Now let us in detail study all these three categories of polynomials, that is linear polynomials, quadratic polynomials, and cubic polynomials. So coming to the textbook, there are several examples for polynomials. In linear polynomials, you can see examples are 2x minus 3, root 3x plus 5, y plus root 2, x minus 2 by 11, 3z plus 4, 2 by 3 u plus 1. All these are examples of linear polynomials. So here you can see in all the example, the highest power of the variable is 1. For example, here 2x minus 3, so power of x is 1. So here you can see 2 by 3 u plus 1, so the highest power of u is 1. So in linear polynomials, the highest power of the variable will be 1. So and the general form of linear polynomial is ax plus b. Okay, in the first example, if you see, a is 2 and b is minus 3, so this can also be written as 2x plus of minus 3. So coming to the quadratic polynomials, in the here these are the example: 2x square plus 3x minus 2 by 5, y square minus 2, 2 minus x square plus root 3x, u by 3 minus 2 u square plus 5, root 5 v square minus 2 by 3 v, then 4z square plus 1 by 7. So in all these examples, you can see the highest power of the variable is 2. So here 2x square, so power of x is 2. In this example, 4z square plus 1 by 7. So here the power of z is 2. So and the general form of quadratic polynomials is ax square plus bx plus c. A, b, c is a, b, c are real numbers, but and a not equal to 0. B can be 0 and c can be also 0. Both a, b and c can be 0, but a cannot be 0. For example, in this last example, you can see b is 0 here actually. That's why we are getting only two terms here, 4z square plus 1 by 7. And coming to examples of cubic polynomials, you can see all these are cubic polynomials. 2 minus x cube. So in the first example, you can see there are only two terms, 2 minus x cube. So here a is minus 1, okay, and b is 0, c is 0, and c is d is 2. Okay, what is the general form of cubic polynomial? It is given by ax cube plus bx square plus cx plus d. So second example is x cube. So in this polynomial, only a is 1, b is 0, c is 0, and d is 0. That's why in this example only x cube is there. Okay, so as I said to you, b can be 0, c can be 0, d can also be 0, all can be 0, but a cannot be 0. It applies to linear polynomials and quadratic polynomials also. And other examples are root 3 x cube, then 3 minus x square plus x cube, 3x square, 3x cube minus 2x square plus x minus 1. See, in this last example, 4 terms is there. All the coefficients of x are there. So a is 3 here, b is minus 2, c is 1, and d is minus 1 here. And as I said you, polynomials may intersect x-axis, okay, at some point. If a linear polynomial intersects x-axis, it's going to intersect x-axis at point minus b by a. I already explained you here. Okay, a linear equation always intersects x-axis at point minus 1 comma minus b by a comma 0. Okay, so b is nothing but the constant term and a is coefficient of x. Now geometrical meaning of zeros of polynomials I already explained you. See, here they've taken a linear polynomial. So y is equal to 2x plus 3 is a linear polynomial. They have given some arbitrary values for x and they have found the corresponding values of y. So when x is equal to minus 2, y we get as minus 1. How we get is by substituting value of x. Now if you put x is equal to minus 2, 2 into minus 2 plus 3 we get minus 1. Similarly, if you put x is equal to y, we get 2 into 2 plus 3, we get totally 7. So x value you can give any arbitrary value, not okay. You can give any values, not an issue. So here they have taken some value and they have got x and y value. Now the first point is minus 2 comma minus 1. So minus 2 comma minus 1 point is here, and the second point is 2 comma 7. 2 comma 7 is here. After getting these 2 points, when we join these 2 points, we get a straight line. So linear polynomials, when we plot it on a xy graph, we get a straight line. Now you can see this straight line meets x-axis at point minus 3 comma minus 3 by 2 comma 0. So what is minus 3 by 2? It is nothing but the constant term divided by the coefficient of a. So minus b by a. So in y is equal to 2x plus 3, what is a? A is b. A is 2, b is 3. So minus b by a is minus 3 by 2. So this polynomial is cutting x-axis at minus 3 by 2 comma 0. So at only one point this line is intersecting x-axis. Therefore we say the number of zeros of this linear polynomial is 1. Okay. And here you can see they have taken example of a quadratic polynomial. So quadratic polynomial, here it is y is equal to x square minus 3x minus 4. So the highest power of x is 2. That's why this is a quadratic polynomial. So here a is 1, b is minus 3, and c is minus 4. Okay. Now to plot the quadratic values, we need many points. Okay. When we, as I told you, when we plot quadratic polynomials, we get parabola like this. Okay. So in linear equation, only 2 points are enough to draw that line. Okay. But in quadratic polynomial, we need to get many values like this. So x they have given arbitrary values of minus 2, minus 1, 0, 1, 2, 3, 4, 5 like this they are given, and the corresponding values of y they have found it. First they have substituted x is equal to minus 2. For x is equal to minus 2, we get minus 2 the whole square minus 3 into minus 2 minus 6 minus 4. So when we solve this one, we get 6. Similarly, when x is equal to minus 1, we get y is equal to 0. When x is equal to 0, y we get minus 4. After this, they have plotted all the points. This is minus 2 comma 6. This is minus 1 comma 0. Then 0 comma minus 4. Like this, they have plotted all the points, and after joining all these points, we get a smooth curve like this, which is a parabola. Now here you can see this parabola, this quadratic polynomial intersects x-axis at 2 points. So therefore we say the number of zeros of this quadratic polynomial is 2. And what are those zeros? Zeros are minus 1 and 4. Zeros are nothing but the values of x when y becomes 0. Simply, so you can see at this point the y is 0. Okay. At for value x is equal to 4, y is equal to 0. For value x is equal to minus 1, y is equal to 0. And now okay, coming to cubic polynomials. Okay, before that some more explanation is there here. So as I told you, the quadratic polynomials will may intersect x-axis at 2 points. Like this it may intersect, or this way it may intersect. See here in this the quadratic polynomial, it is just touching one point on the x-axis. In this you can see the given quadratic polynomial, it is touching x-axis here. Similarly, sometimes it may not touch at all. See this in this case the polynomial is not touching the x-axis at all. So in such a case we say the quadratic polynomial have no zeros. Why no zeros? Means it is not intersecting x-axis. That's it. And at the last they have given example of a cubic polynomial. So the example is this one, y is equal to x cube minus 4x. So the highest power of x here, you can see there are two terms in this polynomial. Highest power of x is 3. That's why this is cubic polynomial. So arbitrarily they have taken some values for x and they have found the corresponding values of y. For x is equal to minus 2, y they got 0. So you can check it out. So if you put minus 2 here, minus 2 the whole cube minus 4 into minus 2, when we solve it we get 0. Similarly, when we put x is equal to minus 1, minus 1 the whole cube minus 4 into minus 1, we get 3. So similarly, like this we get all the values. Now after this we should plot all the values on xy plane. So first point is minus 2 comma 0, second point is minus 1 comma 3, third point is 0 comma 0, fourth point is 1 comma minus 3, and fifth point is 2 comma 0. So after plotting this, you can see the graph is like this. So these are the points which we got it on that table, and they've joined all these points. Now you can see this cubic polynomial intersects x-axis at 3 points. This is the first point, this is the second point, this is the third point. Therefore the number of zeros of this cubic polynomial is 3, because it is intersecting x-axis at 3 points. And the first 0 is minus 2, and the second 0 is 0, and the third 0 is 2. So 0 is nothing but the value of x for which y is equal to 0. So for x is equal to 0, y becomes 0 here at this point, and for x is equal to 0, y becomes 0 at this point. For x is equal to plus 2, y becomes 0 at this point. So there are 3 zeros totally. And they have given 2 more examples here for cubic polynomial. See, this graph is for this polynomial, y is equal to x cube. So here what is the general form of cubic polynomial? It is ax cube plus bx square plus cx plus d. So here only a is 1, b, c, d are 0. That's why we are getting only one term for this polynomial, this cubic polynomial, y is equal to x cube. So when we plot this polynomial, you can see the graph is like this. So this polynomial, you can see it is intersecting x-axis at only one point. Therefore the number of 0 of this cubic polynomial is 1. And what is the value of the 0? It is 0. So at x is equal to 0, y is equal to 0. Okay. Now they have given another example for cubic polynomial. In this cubic polynomial, you can see it intersects at only 2 points only. So the cubic polynomial is actually this one, y is equal to x cube minus x square. So when we they have not shown the values of they have not made a table and shown the values of x and y, but you can check it by yourself. Take this equation, make a table of x and y, give arbitrary values for x and find the corresponding arbitrary values of y, and if you plot it, you will get like this only. This curve you will get. So you can see that this cubic polynomial intersects x-axis at 2 points, at this point 0, 0, and at this point. So therefore this cubic polynomial have 2 zeros. The first 0 is 0, that is the value of x, 0, when y becomes 0, and the other 0 is plus 1. So when x is equal to 1, y is equal to 0. So there are 2 zeros, and the zeros are 0 and 1. So as I told you, cubic polynomials at the most it can intersect x-axis at 3 points. So here in the first example, the cubic polynomial, it is intersecting at 3 points. In the second example, the cubic polynomial is intersecting at only 1 point. In the third case, it is cubic polynomial is intersecting at only 2 points. So the highest number of zeros that a polynomial can have is the highest power of variable it has. Now coming to example here, example 1, look at the graph in figure 9.9 given below. Each is the graph of y is equal to p of x, where p of x is a polynomial. For each of the graphs, find the number of zeros of p of x. So here the first polynomial when plotted, it is coming like this. So what is the number of zeros they are asking? So this polynomial, you can see it is intersecting x-axis at only one point. Therefore the number of zeros of this polynomial is 1. Okay, and in the second example you can see the given polynomial intersects the x-axis at 2 points. First point is here, the second point is here. Therefore the number of zeros is 2, because it intersects at x-axis at 2 points. And in this example you can see the polynomial when plotted, it is coming like this. It is intersecting x-axis at 3 points. First point is here, second point is here, third point is here. Therefore the number of zeros are 3. What are the number of zeros of a polynomial? It is simply the number of points at which the polynomial cuts the x-axis. That's it. So here in the fourth example you can see the given polynomial. This is actually a linear polynomial, that's why it is coming a straight line. So you can see this linear polynomial, it is intersecting x-axis at 1 point. Therefore the number of zeros of this polynomial is 1. And here you can see this polynomial, it is just touching x-axis at only one single point. Therefore the number of zeros of this polynomial is 1. And what is the polynomial here? It is a quadratic polynomial. Okay, so quadratic polynomial always gives a parabola. So in example 2 also, this is a quadratic polynomial, this is the linear polynomial, and this is the cubic polynomial, and first also is a cubic polynomial. Now here in the last example you can see the parabola is like this. So it is intersecting x-axis at 4 points, 1 2 3 4, at 4 points it is intersecting. Therefore the number of zeros of this polynomial is 4. Exercise 9.1, question number 1. The graph of y is equal to p of x are given in the following figure 9.10 below. For some polynomial p of x, find the number of zeros in each case. Okay, so in the first example you can see the line, this is the given polynomial, and it is not intersecting with the x-axis. Therefore the number of zeros for this polynomial is 0. That means we say there is no zeros for this polynomial. Okay, so answer I am writing no zeros. So in the second example you can see the polynomial is in this form, and it is intersecting x-axis at only one point. Therefore the number of zero for this one is 1. Okay, in the third example you can see the polynomial is in this form, intersecting x-axis at this point, at this point, and at this point. There are 3 points where the polynomial intersect x-axis. Therefore the number of zeros for this polynomial is 3. And for this polynomial you can see it is intersecting x-axis at 2 points. Therefore number of zeros for this polynomial is 2. Okay, and for this fifth example you can see this polynomial, it is intersecting x-axis at 1 2 3 4 points. Therefore number of zeros for this polynomial is 4. And in the last example you can see the polynomial intersecting x-axis at 1 point and touching x-axis at 2 other points. Therefore 1 2 3, totally there are 3 zeros for this polynomial. The next topic in this chapter is relation between zeros and coefficients of a polynomial. So you know the linear polynomial is given as p of x is equal to ax plus b. Now what are the zeros of this linear polynomial? So linear polynomial, when we plot on a xy plane, we get a straight line, something like this, okay. And if we extend the straight line, the line will meet at some point on the, will intersect at some point on the x-axis, okay. That point, that coordinate of x is the 0 of the given polynomial. So here when the line meets x-axis, y becomes 0, okay. That means p of x is equal to 0, that is nothing but y. So p of x is equal to 0, so 0 I'll equate to ax plus b. Now 0 is equal to ax plus b, I'll bring b to the left hand side, so minus b is equal to ax, or simply x is equal to minus b by a. So what is minus b? Minus b is nothing but the constant term, and so minus constant term divided by what is a? A is nothing but the coefficient of x, so this is the relation. So x is nothing but the 0, okay. So now this is the relation between the 0 and coefficient of this linear polynomial. Similarly, coming to quadratic polynomial, so in a textbook there is an example. So in your textbook you can see that there is one example, a quadratic polynomial example. P of x is equal to 2x square minus 8x plus 6. So what are the zeros of this quadratic polynomial? So quadratic polynomial, as you know, when we plot it on a graph, it may intersect at two points on the x-axis, okay. It may intersect, it may not intersect, or it may just touch at one point. Let us say it is intersecting. Now how do we find that one? We can plot it and find it. Other way is we can find it algebraically. So whenever the polynomial intersect the x-axis, y coordinates will be 0. That means p of x will become 0. The y coordinate will become 0. So I'll equate the polynomial to 0. Now 0 is equal to 2x square minus 8x plus 6, or simply 2x square minus 8x plus 6 is equal to 0. Now I'll factorize the left hand side. So 2x square, 8x I can write as minus 6x minus 2x. So if I multiply, I should get 6 to the 12 and plus 12x square I'll get, okay. So it is correct. So plus 6 is equal to 0. Now here in the first two terms I can take 2x as common factor, so I'll be left with x minus 3, and now again minus 2, so x minus 3 I'll get is equal to 0. So or 2x minus 2 into x minus 3 is equal to 0, or again I can take 2 here common, so x minus 1 into x minus 3 is equal to 0. So now this is equal to 0 only when x minus 1 is equal to 0, or when x minus 3 is equal to 0, only then it's going to be equal to 0, this above equation. Or when x is equal to 1 it is 0, or when x is equal to 3 it is 0. Therefore what are 1 and 3? 1 and 3 is nothing but the zeros of the quadratic polynomial given, okay. So 1 and 3 are the zeros of the quadratic polynomial. 2x square minus 8x plus 6. Zeros are also called as the root, okay, root of the polynomial. Zeros means it's nothing but the x values for which the y values are 0. For so 1 and 3 are zeros. That means those points are here. Okay. For value for x is equal to 3, y became 0, and again for x is equal to 1, y became 0. Okay, you can see here. Now I'll add the zeros, that is 1 plus 3. So 1 plus 3 if I add, now 1 is one of the zeros and 3 is one of the zero. I'll consider them as alpha and beta. Okay, so if I add the zeros, I'll get how much? 1 plus 3 is equal to 4. 4 is also equal to minus 8 by 2. Okay, so what is minus 8? Minus 8 is nothing but b. Okay, and what is 2? 2 is nothing but a. So simply alpha plus beta, that is sum of the zeros is equal to minus b by a. That means constant term. Sorry, here it's coefficient of x. So b is coefficient of x divided by a. A is coefficient of x square. Coefficient of x square. Similarly, if I multiply 1 and 3, so 1 and 3, 1 into 3, so 1 are considered as alpha and 3 as beta. So 1 into 3 gives 3. Now 3 is also equal to 6 by 2. So 6 is also equal to c. Okay, c, and 2 is equal to a. So c is nothing but the constant term of the quadratic polynomial, and a is nothing but the coefficient of x square. So alpha into beta is equal to constant term divided by coefficient of x square. Coefficient of x square. So quadratic polynomial is given by ax square plus bx plus c. Okay, a is 2 here, b is minus 8, and c is equal to plus 6. So in general, for any polynomial given by ax square plus bx plus c, so quadratic polynomial specifically, so for any quadratic polynomial, if I factorize it, I'll get this equal to k times of x minus alpha into x minus beta. You can see the previous page. In the previous example only, I factorized the polynomial and I got in this way k into x minus alpha into x minus beta, where alpha and beta are zeros. Zeros are the roots of the given quadratic polynomial. Okay, now this I can write as k into, now I will multiply x minus alpha into x minus beta, x into x minus beta minus alpha into x minus beta. Now this is equal to k into x square minus x into beta minus alpha into x minus into minus plus alpha beta I will get. Okay, so this is equal to k into x square. So minus x I will take common, I will get alpha plus beta plus alpha beta. Okay, now I will open the square bracket also, kx square minus x into alpha plus beta plus alpha beta, k into x alpha, okay, and alpha beta into k. Now if I compare the coefficient of x term and coefficient of x term and constant, I'll get, see here, ax square, in the left hand side ax square is there, and in the right hand side kx square is there. Therefore a is equal to k. Similarly, comparing the coefficient of x term, I'll get b is equal to minus k into alpha plus beta. Okay, this I'll mark as 1, or b is equal to minus k by alpha plus beta here. So, or in the left hand side, if I multiply both numerator and denominator by minus 1, I'll get minus b by k, or simply b by minus k can be written as minus b by k also. Okay, this is equal to alpha plus beta. So minus b by k is also equal to a. So minus b by a is equal to alpha plus beta. So the product of zeros is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. This I'll mark as 2. Now I'll compare the constant term of the left hand side and right hand side. Okay, this I'll mark as a. Now if I compare the constant term of the left hand side of a and the constant term of the right hand side of a, I'll get c is equal to alpha beta into k, or if I cross multiply, c by k is equal to alpha into beta, or c is equal to, what is k? K is equal to a. Okay, c is equal to k. How? From equation 1 we know that a is equal to k, therefore in place of k I'll substitute a. So here also from 1. Okay, now it's clear for you that for any given polynomial, given quadratic polynomial ax square plus bx plus c, the sum of the roots is equal to minus b by a, and the product of the roots is equal to c by a, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term, and alpha and beta are nothing but the roots of the polynomial. Alpha and beta are nothing but the zeros of the quadratic polynomial. Zeros means the values of x for which the y values is equal to 0. If you plot quadratic polynomial on a graph sheet, xy plane, so we get something like this. Okay, suppose if it is like this, now you can check that the polynomial intersects x-axis at 2 points. Okay, like this. Here you can see. Now these 2 points, one will be alpha and other will be beta. Alpha, beta are nothing but the values of x for which the values of y is 0. Okay, this is beta. If you see in the textbook, the same explanation has been given. So ax square plus bx plus c. So this quadratic polynomial will have 2 zeros. So when we factorize, we'll get this form, in this form, k into x minus alpha into x minus beta, where alpha and beta are the zeros. So if we multiply and compare, when we compare the coefficients of x square, x and constant term, we get this relation: alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Now coming to the cubic polynomial is given by ax square, ax cube plus bx plus cx plus d. So the highest degree here is 3. Therefore cubic polynomial will have 3 zeros. At the most it will have 3 zeros. So when we factorize cubic polynomial, we get ax cube plus bx square plus cx plus d. We will get this equal to k into x minus alpha into x minus beta into x minus gamma, where alpha, beta and gamma are zeros. zeros or roots of the cubic polynomial. Okay, now this I'll mark as A. So when I multiply the right hand side, okay, multiply the right hand side and equate the coefficient of x cube, x square, x and d term, okay, I'll get alpha plus beta plus gamma is equal to minus b by a, and also I'll get alpha beta into gamma is equal to minus d by a, and also I'll get alpha beta plus beta gamma plus gamma alpha is equal to c by a. So multiplication it is left to you. In equation A, the right hand side you should multiply, and whatever you get, you should compare the left hand side. You should compare the coefficients of x cube, x square, x and d term. Then you get these three equalities. Now what are alpha, beta, gamma? Alpha, beta, gamma are nothing but the values of x for which y value becomes 0. So this is alpha, this is beta, and this may be gamma. So for x is equal to alpha, y becomes 0, and also for x is equal to beta, y becomes 0, and also for x is equal to gamma, the y value becomes 0. So not necessary that always it should have 3 zeros. Sometimes it may have 2 zeros or just 1 zeros also. See, in this case you can see this is intersecting x axis at only one point. Now if you see in the textbook, okay, see, in general it can be proved that if alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a, alpha beta gamma is equal to minus d by a. Okay, they have skipped some steps, and that's not an issue. In equation A, if you expand the right hand side, you can still get this one. You should just compare the coefficients of x cube, x square, x and constant term. In the textbook there are several worked examples. You can go through it. All are very simple and self-explanatory. So here these problems are related to quadratic polynomials. This is also related to quadratic polynomial, and this problem is related to cubic polynomial, and this example 5, it's not in examination point of view. They have given here not from the examination point of view. That means this will not come for the examination, just for your explanation they have given you, but you can go through for your understanding. All are self-explanatory. You should make a habit of reading textbook. In the long run it will be very helpful when you are doing your higher studies. That time many things you can learn by yourself only. So right now only you should make a habit of reading textbooks. Exercise 9.2, first question. Find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. So first sub question, it is x square minus 2x minus 8. So this is nothing but y is equal to p of x is equal to x square minus 2x minus 8. So now x square minus 2x minus 8, if I'll factorize it. Okay, now what to factorize? I should multiply. Now first term is x square, last constant term is minus 8, so I'll get x square into minus 8 is minus 8 x square. Now I should split the middle term such that if I multiply I should get minus 8 x square. So minus 2x I can split as 4x plus 2x. How I got that one? So 8, if I factorize 2 4s are 8, 2 2s are 4, then 2 1s are 2. Now 2 into 2 is 4, 4 into 2 is 8. So therefore I'll take 4x plus minus 4x plus 2x. So minus 4x plus 2x, if I add, I'll get minus 2x only, but if I multiply, I'll get minus 8x square. That way I should write. So minus 8. Okay, so this is equal to, now here I'll take x as common factor, x into x minus 4 plus, in the third and fourth term I can take 2 as common factor, x minus 4. So if I have done correctly, I'll get these two terms same only, x minus 4, you can see. So now I can write as x plus 2 and x plus 4. Okay, now I have factorized p of x. Now to find this root, to find the zeros, I should equate this to 0. So x plus 2 into x plus 4 is equal to 0. Why I should equate 0? So zeros is nothing but the values of y for which x, values of x for which y is equal to 0. Okay, that's why I'll equate this to 0. Now x plus 2 is equal to 0, or x plus 4 is equal to 0, or x is equal to minus 2, or x is equal to, okay, this is plus minus, sorry, this is minus. So x minus 4 is equal to 0, x is equal to plus 4, x is equal to minus 2 and x is equal to plus 4 are the zeros of the given polynomial. Now I'll find the sum of these zeros. Minus 2 plus 4, how much is this? I'll get plus 2. So this is also equal to minus b by a. You can check it out. What is my minus? What is b? B is minus 2, coefficient of x. And what is a? A is 1. So this I'll get minus into minus is plus 2 by a. So sum of these zeros is equal to minus b by a. So this is verified. Now I should check whether the product of the zeros is equal to c by a. So product of zeros is minus 2 and into 4. I'll get minus 8. This should be equal to c by a. So we'll check what is c. C is minus 8. What is a? A is 1. So this is minus 8. So both are verified. So graphically what it means, minus 2 and x are the zeros of the given polynomial. So graphically it means, this is not necessary to show in examination, just for your understanding I am showing. This is x axis, this is y axis. If we plot this given polynomial, it will be like this. Okay, it will be like this, or it may be like this also. I'm not sure. When we plot it, we'll come to know exactly. It may be it may be in this way also. Okay, and at point x is equal to minus 2, it is intersecting x axis, and at point x is equal to 4 also, it is intersecting x axis. So in any of these two form, this polynomial will be there. If you want, you can plot, check and verify. So this is not necessary for examination to show it, just for your understanding I am showing it. Okay, exercise 9.2, question number 1, sub question 2. Given polynomial is 4x square minus 4s plus 1. So I'll factorize this one. This is equal to 4s square. Now 4s square into 1 is 4s square only. Now 4, if I factorize, 2 2s are 4. Okay, now I should split middle term such that if I multiply, I should get 4s square. So now middle term I can split as minus 2 minus 2s minus 2s. So minus 2s is minus 4s. Minus 2s into minus 2s, I'll get plus 4s square. So plus 1. So this is equal to, now in the first two terms I can take 2s as common factor. I am left with s minus 1. Then again minus sorry, I am left with 2s minus 1. Now again here, if I'll take 1 as common factor, I am left with minus 1 as common factor. I am left with 2s minus 1. Okay, so this is equal to 2s minus 1. I can write as 2s minus 1 into 2s minus 1. Now I'll equate this to 0. 2s minus 1 into 2s minus 1 is equal to 0. I'll equate this to 0. Why I am equating this to 0? To find the zeros. So what is 0? 0 is nothing but the values of s for which the y value is equal to 0. That means 2s minus 1 is equal to 0, or 2s minus 1 is equal to 0, or s is equal to 1 by 2. If we simplify, here also if we simplify, I'll get s is equal to 1 by 2. So 2s minus 1 is equal to 0, right? If I bring this to the right hand side, I'll get 2s is equal to plus 1, or s is equal to 1 by 2 I'll get. So I'm getting two zeros and both are equal in this case. Now I'll check the sum of these zeros. First 0 is 1 by 2, second one is 1 by 2. So 1 by 2 is LCM is 2, 1 plus 1. So I get 2 by 2 is equal to 1. 1 by 1 is equal to 1 only. So this should be equal to minus b by a. Minus b by a. Check what is minus b. Minus b is minus of b, minus of minus 4. So b is minus 4 there in the given equation. Okay, so 4s square minus 4s plus 1 means that is ax square plus bx square plus c. Okay, by a. What is a? A is 4. So minus 4 into minus 4 is plus 4. So 4 by 4. So I'll get 1 only. So first condition is verified. Now product. I'll check the product of these zeros. 1 by 2 into 1 by 2. So 1 by 2 into 1 by 2 is 1 by 4. So this should be equal to c by a. What is c? C is 1. You can see a is 4. So 1 by 4. So it is verified. Second condition also is verified. So here in this problem, if we plot this one in xy plane, so in place of x, if we take horizontal line as s and vertical line as y, okay, we make it okay, and when we plot, we make it a curve something like this. There are two zeros. Okay, the curve may be like this. The curve is intersecting the s axis at 1.4. It is intersecting at 2 times, or it may intersect this way also, y s. Okay, or it may be intersecting this way also 2 times at this point. This point is 1 by, sorry, it's 1 by 2. Okay, at point 1 by 2 the curve is passing through s axis. So in place of x axis we have taken s. In place of x we have taken s. Okay, exercise 9.2, question number 1, sub question 3. It is 6x square minus 3 minus 7x. So now I'll rearrange this one. I can write as 6x square minus 7x minus 3. Okay, so this is in the form of ax square plus bx plus c. Okay, now first term into third term is 6x square into 3. 6 3s are 18, 18x square. Now 18 if I factorize, 2 9s are 18, 3 3s are 9, 3 1s are 3. Now 6x square minus 7x minus 3 I can write as 6x square. So 6 1s are 6. 9 2s are 18. Okay, 9 2s are 18. So 7x I'll write as minus 9x plus 2x. So minus 7x into 2x is 18x square. Okay, this is 6x square into minus 3 is minus 18x square. Okay, so 9x into 2x is minus 18x square. So minus 3. Now this one I can take 3 common factor, 3x in the first two terms. So I am left with 3 2s are 6. So 2x I am left. Then minus 3 3s are 9. Okay, then in the third and fourth term I can take 1 as common factor. I am left with 2x minus 3. So 3x plus 1 is equal to 3x plus 1 into 2x minus 3. Now I'll equate this to 0. 3x plus 1 into 2x minus 3 is equal to 0. Why I should equate to 0? To find the zeros or to find the roots I should equate to 0. So that means 3x plus 1 is equal to 0 or 2x minus 3 is equal to 0. So or now if I simplify for x is equal to minus 1 by 3. Okay, here if I'll get x is equal to 3 by 2. So these two are the zeros of the given cubic polynomial. Now I'll sum the two zeros. So minus 1 by 3 plus 3 by 2 for sum it. So LCM is 6. So here minus 1 into 2 plus 3 into 3 into 3 I'll get. So this is equal to 6. So minus 1 into 2 is minus 2 plus 3 3s are 9. I'll get plus 7 by 6. So plus 7 by 6, this should be equal to minus b by a. What is minus b? So minus b is minus 7. So minus of minus 7 by a is 6. So I'll get 7 by 6 only. So first condition is satisfied. And now product. So minus 1 into minus 1 by 3 into 3 by 2. I'll get as 3 3 here, 3 3 will get cancelled. I'll get minus 1 by 2. So this should be equal to c by a. What is c? C is minus 3. So minus 3. What is a is? A is 6. So 3 1s are 3, 3 2s are 6. So 1 by 2 minus 1 by 2. So this condition also is satisfied. So this quadratic equation, when you plot actually on an xy plane, so it will be something like this. So the graph, it is intersecting x-axis at point minus 1 by 3 and 3 by 2 on the x-axis, or it may be intersecting this way also. We don't know. If we plot, we will come to know exactly. So in either of the two form, it will be intersecting the x-axis, okay, at point 1 by 3 and 3 by 2. So zeros of a quadratic equation is nothing but the values of x for which the y values becomes 0. That's why we equated this to 0. We equated the polynomial to 0 and then we found the values of x. Exercise 9.2, question number 1, sub question 4. The given polynomial is 4x square plus 8u. So this is a polynomial in the form of ax square plus bx plus c. So here c term is 0. That's why in the given polynomial only two term is there. That is u square term and u term. C is 0. So now 4u square plus 8u I can write as, I'll take 4u as common factor. So u plus 2 I'll write. Now I will equate this to 0, 4u into u plus 2. To find the zeros or to find the root, I should equate the given polynomial to 0. Now 4u is equal to 0 or u plus 2 is equal to 0. Now u is equal to 0 by 4 or any number by 0 is, sorry, 0 by any number is 0 only. U is equal to 0. So u is equal to 0. Now here coming this side, if I take this 2 to the right hand side, u is equal to minus 2. So okay, u is equal to minus 2. So u is equal to 0 or u is equal to minus 2 are the zeros of the given polynomial or the roots. Okay, the zeros are u is equal to zeros are 0 and minus 2. Okay, now some property I'll check. I'll add 0 plus of minus 2, 0 plus of minus 2 is 0 minus 2, I'll get minus 2. So this should be equal to minus b by a. So what is b? b is 8. So minus of 8 by a is 4. So I'll get minus 4 ones are 4, 4 twos are 8. So minus 2 I'll get. So it is verified. Now I'll check the product property. So 0 into minus 2 is equal to 0. So this should be equal to c by a. What is c? C is 0. So in the given polynomial, c term is missing. That means c is 0. So 0 by a is 4. 0 by any number is 0 only. So this property also is verified. Now the problem is over. But for your understanding, I am drawing the graph. If we draw the graph taking horizontal line as u axis and vertical line as y axis, so the roots are, the zeros are 0 and minus 2. So 0 and minus 2. The given polynomial will be like this. So it passes through minus 2 and 0 of the u axis, or it may be even like this. This is u, this is y. It is passing through minus 1 and 0, minus 2 and 0. The given polynomial may be like this also. So we don't know whether this or that. When we give some arbitrary values and we plot, and when we plot it, we'll come to know in which form it's going to be there. Just for your understanding sake, I'm drawing this graph. Okay. Exercise 9.2, question number 1, sub question 5. The given polynomial is t square minus 15 is equal to 0. So this is the form of a square, ax square plus bx plus c. Okay. Now here b term is 0. That's why here we are getting only t square minus 15 and c is minus 15. Okay. Now t square minus 15, I should factorize this. Now this I can write as t square. 15 I can write as square root of 15 the whole square also. Okay, square root of 15 the whole square is 15 into square root of 15 into square root of 15. I'll get just 15. So now t square minus square root of 15 the whole square. This is in the form of a square minus b square. So this is equal to a plus b into a minus b. So using that formula I'll expand. This is equal to t plus root of 15 into t minus square root of 15. Now I will equate this to 0. T plus square root of 15 into t minus square root of 15 is equal to 0. To find the root, to find the zeros, we need to equate it to given the we need to equate the given polynomial to 0. Now what this means, t plus root, so this is equal to 0 when one of these two is equal to 0. Okay, so when t plus root 2 is equal to 0, or if t minus root 15 is equal to 0, the given polynomial is 0. So what this means, t is equal to, if I bring 15 to the right hand side, minus root of 15, or t is equal to, if I bring root of 15 to the right hand side, I'll get plus root of 15. So t is equal to minus root 15 or t is equal to plus root 15 are the two roots or the two zeros of the equation. The zeros are minus root of 15 and plus root of 15. So now some property I will check. When I add minus root 15 plus root 15, what I'll get? I'll get 0. Both will get cancelled. So this should be equal to minus b by a. What is b? B is 0. You can check it out. There's no b term only there in the given polynomial. B is 0 by a is 1. So 0 by 1 is 0 only. So this condition is verified. Now product. Now root 15 into root 15 plus root 15 into minus root 15, I'll get minus of 15, because root 15 into root 15 is 15 only, and there is one minus sign which will be there as it is. So this is minus 15. So this should be equal to c by a. Also, what is c? C is minus 15. You can check it out in the main equation, main polynomial. So minus 15 by a is 1. So minus 15 by 1 is minus 15 only. So this one, if we plot it on a graph, if we take x-axis as t, okay, if we take x-axis as t and if we plot it, we get, so plus, so graph will be like this. The polynomial will intersect the t-axis at minus root 15 and plus root of 15. Okay, or it may be like this also in the reverse order. Why this is t, it could be like this also. I'm just drawing a rough graph. Okay, in either of the two form it could be there. So this is just a rough figure I'm drawing. You can arbitrarily give values of t and find the corresponding values of y, and you can check it. You can really plot and check whether it looks in the first form or in the second form. Both possibilities I have given. So this is not necessary to write in exam, not necessary to show the graph. I'm just for your understanding sake I'm writing. Exercise 9.2, question number 1, sub question 6, given polynomial is 3x square minus x minus 4. So this is of the form of ax square plus bx plus c. So a is 3 here, b is minus 1 and c is minus 4. So first term and third term, 3x square into minus 4 is 3 4s are 12, 12x square minus 12x square I'll get. So I should split middle term such that if I multiply I should get minus 12x square. So 3x square minus x minus 4 I can write as 3x square. So middle term I am going to split. I'll split minus x as minus 4x minus plus 3x. So minus 4x plus 3x is minus x only. Minus 1x I'll get. Minus 1x x means just x minus x. So minus 4x into plus 3x is minus 12x square I'll get. Okay, minus 4. So this is equal to, here x I can take common, 3x minus 4 is left. Here 1 I can take common, 3x minus 4 is left. So this is equal to x plus 1 into 3x minus 4. So now I'll equate this to 0. X plus 1 into 3x minus 1 is equal to 0. Why I am equating it to 0? To find the zeros I should equate to 0, or to find the root. To find the root, if we should equate the polynomial to 0. So polynomial I have factorized and converted in this form. Now I have equated to 0. Now x plus 1 is equal to 0, or 3x minus 4 is equal to 0. Now if I bring 1 to the right hand side, I will get x is equal to minus 1, or here if I take minus 4 to the right hand side, I will get plus 4. Okay, 3x is equal to plus 4 I will get. If I cross multiply, I will get x is equal to 4 by 3. So x is equal to minus 1 or x is equal to 4 by 3 are the two zeros of the given quadratic polynomial. So therefore the zeros are minus 1 and 4 by 3. Zeros are simply roots. Now some property I'll check. I'll add the zeros. Minus 1 plus 4 by 3. So LCM is 3. So here minus 1 into 3 I'll get in the numerator of the first term, plus 4. So minus 3 plus 4 by 3. So this minus 3 plus 4 is 1 by 3. So this should be equal to b by a. What is b? B is it's minus b by a. So minus b, b is minus 1. So minus into minus 1. So a is 3. So minus into minus 1 is plus 1 by 3 I'll get. So this condition is satisfied. Now I'll check the product. So minus 1 into 4 by 3. So my 1 4s are 4. So minus 4 by 3. So this should be equal to c by a. What is c? C is minus 4. Okay, and a is 3. So it is satisfied. So minus 1 and 4 by 3. So if you actually plot the graph, you'll get like this, x y. So minus 1 is one of the root, and 4 by 3 is one of the root. So this is minus 1, this is 4 by 3. So the given polynomial passes through these points, or it may pass this way also. You can check it out. In either of the two form, the graph is going to be. So this is just an assumption. It may be in the first form or it may be in the second form. when we really plot it, we'll come to know how it's going to be. Exercise 9.2, question number 2, sub question 1. Find the quadratic polynomial each with the given number as the sum and product of its zeros respectively 1 by 4 and minus 1. That means what they given is, they have given alpha plus beta and alpha into beta. Alpha plus beta is 1 by 4 and alpha into beta is minus 1. So alpha plus beta is, we know that it's also equal to b by a. Okay, alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Okay, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term of the polynomial, of the quadratic polynomial. So minus b by a is equal to 1 by 4, and alpha into beta is c by a is equal to 1. Okay, if a is equal to 1, I'll get minus 1 by 1, sorry, minus b by 1 is equal to 1 by 4. If I cross multiply, minus b into 4 is equal to 1 into 1 I'll get. So, or minus b is equal to 1 into 1 is 1, so 1 by 4, or minus b is equal to 1 by 4, or b is equal to 1 by 4. I can take the negative sign to the right hand side. Okay, sorry, okay, if I take negative sign, it becomes b is equal to minus 1 by 4. Okay, so b is 1 by 4. Now c by a is equal to 1. So for a is equal to 1, I will get c is equal to 1 into a. So c is equal to 1 into a, I have taken 1. So 1 into 1 is 1. So c is equal to 1. So the first quadratic equation that satisfies the given condition is ax square plus bx plus c is equal to 0. So substitute the values of a, b and c in that one. So a is 1 I have taken, and b is, sorry, x square as it is, plus what is b is minus 1 by 4 into x plus c is 1 is equal to 0. So 1 into x square is x square, so plus into minus is minus, here minus 1 by 4, x plus 1 is equal to 4. Now multiply throughout by 4. What will I get? 4 into x square minus 1 by 4 into x plus 1. Right hand side also should multiply, only then it will be correct. I can't multiply only left hand side and leave right hand side as it is. So 4 into 0, but here now in the right hand side 4 into 0 is 0 only. So in the left hand side I'll get 4x square minus, so 4, when I multiply 4 with 1 by 4 will get cancelled. I'll be left with 1x only, plus 4 ones are 4, or 4x minus x plus 4 is equal to 0. So this is the quadratic equation, and the quadratic polynomial will be, therefore the quadratic polynomial is 4x minus x plus 4. Okay. Exercise 9.2, question number 2, sub question 2. The given values are root 2 and 1 by 3. So that means alpha plus beta is equal to root 2 and alpha into beta is equal to 1 by 3. So alpha plus beta is also equal to minus b by a. Minus b by a is equal to root 2, and alpha into gamma is c by a. C by a is equal to 1 by 3. So for a is equal to 1, I'll get minus 1 by minus b by 1 is equal to root 2, and here c by 1 is equal to 1 by 3. So now if I cross multiply, minus b is equal to root 2 into 1. So minus b is equal to root 2 into 1 is root 2 only. So minus b is equal to root 2, or b is equal to minus of root 2. Now here c by 1 is equal to 3, or c is equal to, if I cross multiply, 1 into 1 by 3. 1 into 1 is 1 only. So 1 by 3 I'll get. So c is equal to 1 by 3. Okay. Now therefore one of the quadratic equation which satisfies the given condition is ax square plus bx plus c is equal to 0. So a we have taken as 1, x square, b is minus root 2 plus of minus root 2 into x, plus c is 1 by 3 is equal to 0. So 1 into x square is x square only. So this plus into minus is minus root 2x. So minus root of minus root 2 into x plus 1 by 3 is equal to 0. Now multiply throughout by 3. If I multiply 3 into x square minus root 2x plus 1 by 3 is equal to 0. 0 into 3. So this I will get 3x square minus root 2 into 3 x plus, now here 3 and 3 will get cancelled, 1 is equal to 0, or simply 3x square minus 3 root 2x plus 1 is equal to 0. Therefore the quadratic polynomial is 3x square minus 3 root x plus 1. Exercise 9.2, question number 2, sub question 3. The given values are 0 and root 2 of y. So what it means is alpha plus beta is equal to 0 and alpha into beta is equal to root 5. So alpha plus beta is nothing but equal to b by a, minus b by a. So minus b by a is equal to 0, and alpha into beta is c by a is equal to square root of 5. So for a is equal to 1, I'll get minus b by 1 is equal to 0, or minus b is equal to 0 into 1 cross multiplication, or minus b is equal to 1 into 0 is 0 only, or b is equal to 0. Minus b is equal to 0, I can write as b is equal to 0. Okay, because if I multiply both the side by minus 1 into minus b into minus 1 is equal to 0 into minus 1. So 0 into anything is 0 only. So minus b into minus 1 is plus b I'll get. Okay, that's why minus b any variable, or in this case minus b is equal to 0, I can write as b is equal to 0. Now coming here, c by a is equal to root of 5, or c is equal to root 5 into a, or root 5 into a is 1. So root 5 into 1 is root 5 only. Okay. Now one quadratic equation that satisfies the given condition is ax square plus bx plus c is equal to 0. Now substitute the values of a, b and c in that one. A is 1, x square, plus b I got 0 into x, plus c I got root of 5 is equal to 0. So x square, 0 into anything is 0, so 0 into x is 0, plus root 5 is equal to 0. So x square plus root 5 is equal to 0. So this is the quadratic equation. Therefore quadratic polynomial is x square plus root 5. When we equate polynomial to some value, it is equation. Otherwise we call it is just a polynomial. Okay. Exercise 9.2, question number 2, fourth sub question. The given values are 1 and 1, that is alpha plus beta is equal to 1 and alpha into beta is equal to 1. So alpha plus beta is also equal to minus b by a. Minus b by a is equal to 1 and alpha into beta is nothing but c by a. C by a is equal to 1. So for a is equal to 1, I will get minus b by 1 is equal to 1, or if I cross multiply, minus b is equal to 1 into 1. So 1 into 1 is 1 only. So minus b is equal to 1, or b is equal to minus 1. Okay. So here c is equal to 1, or c is equal to 1 into a, or c is equal to 1 into a is 1. So c 1 into 1 is 1. So c is equal to 1, b is equal to minus 1. Therefore one equation that satisfies the given condition is ax square plus bx plus c is equal to 0. What is the condition? A is equal to 1, b is equal to minus 1, c is equal to 1, and alpha plus beta is equal to 1, and c by a is equal to 1. So substitute the values of a, b and c here. A is 1 x square plus b is minus 1 into x, plus what is c is 1. So 1 into x square is x square, so plus into minus is minus, 1 into x is x, plus 1 is equal to 0. Therefore the polynomial, the quadratic polynomial is x square minus x plus 1. So that's it. Okay. When we equate this to polynomial to some value, then it is an equation. Otherwise it is just called a polynomial. So x square minus 1 plus 1. Exercise 9.2, question number 2, sub question 5. The given values are minus 1 by 4 and plus 1 by 4. That means alpha plus beta is equal to minus 1 by 4, and alpha plus beta is equal to plus 1 by 4. Sorry, alpha into beta is plus 1 by 4. So alpha plus beta is also equal to minus b by a. So minus b by a is 1 by minus 1 by 4. So here alpha beta is alpha into beta is c by a. c by a is equal to plus 1 by 4. So for a is equal to 1, I will get minus b by 1 is equal to minus 1 by 4. So if I cross multiply, minus b is equal to minus 1 into 1 by 4. So minus b is equal to 1 into 1 is 1 only, so minus 1 by 4. So both side negative sign is there, I can cancel. So b is equal to 1 by 4. Coming here, c is equal to 1 by 4 into a, I will get here 1 by 4 into a. So c is equal to 1 by 4, a is 1, so 1 into 1 is 1 by 4. So c is equal to 1 by 4. b also I will get as 1 by 4. Therefore one equation that satisfies the given condition is, what is the condition? Alpha plus beta is equal to minus 1 by 4 and alpha into beta is 1 by 4. So that equation is ax square plus bx plus c is equal to 0. So where a is equal to 1, b is equal to 1 by 4 and c is equal to 1 by 4. So substitute the values. 1 into x square plus b is 1 by 4 into x plus c is 1 by 4 is equal to 0. Now multiply throughout by 4. So I will get 4 into x square plus 1 by 4x plus 1 by 4 is equal to 0 into 4. Both left hand side and right hand side we should multiply. So here I will get 4x square. So 4 into 1 by 4, 4 will get cancelled, I will get just x plus 4 here also. 4 into 1 by 4, 4 will get cancelled, I will get only 1. So right hand side is 0 only. So this is a quadratic equation. Therefore quadratic polynomial is 4x square plus x plus 1. That's it. So polynomial, when we equate to some value, it becomes an equation. Exercise 9.2, question number 2, sub question 6. Alpha plus beta is equal to 4 and alpha into beta is 1. Alpha plus beta is equal to 4 and alpha into beta is equal to 1. So alpha plus beta is also equal to minus b by a. So minus b by a is equal to 4. Alpha into beta, alpha beta is c by a. C by a is equal to 1. Now for a is equal to 1, I will get minus b by 1 is equal to 4. So if I cross multiply, minus b is equal to 4 into 1. So minus b is equal to 4. So or b is equal to 4. Minus b is equal to 4, I can write as minus b is equal to 4, I can write as b is equal to minus 4. Okay, the negative sign will come to the right hand side. Now c by a is equal to 1 or c is equal to 1 into a. So c is equal to 1 into a is 1. So c is equal to 1. So a is equal to 1, b is equal to minus 4 and c is equal to 1. Therefore one equation that satisfies this condition is ax square plus bx plus c is equal to 0, which is that condition alpha plus beta is equal to 4 and alpha into beta is equal to 1. So now substitute the values of a, b and c here. A is 1 into x square plus b is minus 4 into x plus what is c is 1 is equal to 0. Now 1 into x square is x square only. So plus into minus is minus 4 into x is 4x plus 1 is equal to 0. So this is the equation. Therefore quadratic polynomial is x square minus 4x plus 1. Okay. The next topic in this chapter is a division algorithm for polynomials. Now consider one number 10, and suppose if the factors of 10 are 10, suppose if we know only one factor, that is say 2. 2 is a factor of 10. What is the other factor of 2? How to find it? It's very simple. So 10, if we divide by 2, I get 2 5s are 10. Okay, so 5 is the other factor. So if I know one factor, I can find the other factor also. Similarly 15. So now 5 is one of the factor of 15. What is the other factor of 15? So it's very simple. 15, if I divide by 5, 5 3s are 15. Okay, therefore the other factor of 15 is 3. So if one factor is known, other factor also we can find by division method. So the same thing applies here also in case of polynomials. Now consider one polynomial which is an example in your textbook also. X cube minus 3x square minus x plus 3. So for this polynomial, there will be this is, so what is the degree of this polynomial? 3, because the highest power of x is 3. Okay, there will be 3 factors. Suppose if I know one factor, suppose if x minus 1 is one of the factor, I should find the other factors. So I can easily do it. It's very easy. What I'll do is I'll divide the given polynomial x cube minus 3x minus x plus 3 by one of the factor which I already know. So x minus 1 is the factor which I know. So if I divide, so I'll get x. So if I multiply x minus 1 into x square, I'll get x square into x is x cube, and minus 1 into x is minus x square. So this is x square. So here now I should subtract. So I'll change its sign. So this 2 will get cancelled. Plus 3x square minus 3x square plus x square is minus 2x square. So minus x plus 3 is remaining. Now again, if I multiply this with multiply x minus 1 by minus 2x, so I'll get x into 2x is x into minus 2x is minus 2x square. Then minus 1 into minus 2x is plus 2x I'll get. So now again I'll change this signs. This 2 will get cancelled. Now minus x in minus x minus 2x is minus 3x plus 3. Now if I multiply x minus 1 by minus 3, okay, if I multiply by minus 3, I'll get x into 3 is minus 3x, minus 1 into minus 3 is plus 3. So here I'll change the signs. Now everything will get cancelled. I'll get 0 as the remainder. So x minus 1 was one of the factor. So now x minus 1 into x square minus 2x minus 3. So this way I can write x cube minus 3x square minus x plus 3 is equal to x minus 1 into x square plus x square minus 2x minus 3. So here the dividend is first one dividend, x cube minus 3x square minus x plus x is the dividend, and the divisor is x minus 1. Okay, and the quotient is x square minus 2x minus x. Okay, here we did not get any remainder. There will be a remainder also sometimes. Okay. Now again I can write this is equal to x minus 1. Now I can factorize x square minus 2x minus 3. So that one, if I factorize, I'll get as x plus 1 and x minus 3. Therefore the factors of x cube minus 3x square minus x plus x are x minus 1 and x plus 1 and x minus 3. So all these are factors. Okay, these are factors of the given polynomial, and from the factors I can find the zeros. In your textbook you can find several worked examples. So divide 2x plus 3x plus 1 by x plus 2. So it's a simple division. All the procedure is given. It's all self-explanatory. So in the exercise problem we have several problems to do. So I won't be explaining all these things. It's all self-explanatory. Read and understand by yourself. There's another example here. Divide 3x square plus x square plus 2x plus 5 by 1 plus 2x plus x square. So read the procedure, and here you can see division algorithm for polynomials. So what does this division algorithm for polynomial says? So it says if p of x and g of x are any two polynomials with g of x not equal to 0, then we can find polynomials q of x is equal to r of x, such that p of x is equal to g of x into q of x plus r of x. So this is not at all tough to remember. P of x is nothing but the dividend, g of x is nothing but the divisor, and q of x is nothing but the quotient, and r of x is nothing but the remainder. Okay, so here q, it stands for quotient and r stands for remainder. And here one thing you should observe, that the degree of remainder will be less than the degree of divisor, g of x. Okay, in the textbook there are some more examples regarding division. In this example you can see divide 3x square minus x cube minus 3x plus 5 by 1 minus x square, and verify the division algorithm. So the division goes on. After division there is one remainder and one quotient. Now divisor into quotient plus remainder we should get equal to dividend. So they verified, and ultimately they are getting back the dividend. Okay, now in the next example, see here in this polynomial 2x to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. In this one they have given two zeros, that is root 2 and minus root 2. We should find the other zeros. Okay, two zeros are root 2 and minus root 2. Find the other zeros of this polynomial. That's the question. So if root 2 and minus root 2 are the zeros, x minus root 2 into x minus root 2 is one of the factor, and x plus root 2 is one of the factor. Now they have multiplied these two factors, we get x square minus 2. Okay, now they have divided the given polynomial by this x square minus 2. After this there is some quotient here. Now if we factorize this quotient, again we will get two more roots, two more zeros of the given polynomial. So here you can see now dividend is expressed as divisor into quotient. Okay, x square minus 2 into 2x square minus 3x plus 1. Again if we factorize 2x minus 3x plus 1, we get the remaining two zeros, that is 1 by 2 and 1. 1 by 2 and 1 are the zeros of the given polynomial. Okay, root 2 and minus 2, root 2 were already given. We found out 1 by 2 and 1, the other zeros of the polynomial. Exercise 9.3, question number 1, sub question 1. So divide the polynomial p of x by the polynomial g of x. Okay, so p of x is equal to x cube minus 3x square plus 5x minus 3, and g of x is equal to x square minus 2. So let us proceed. X cube minus 3x square plus 5x minus 3. So I should divide now. So x square minus 2. So I should choose the multiplier such that the first term should get cancelled. Now if the first term is x, you can see that x into x is x cube. So I can cancel the first term now. So that way I should choose. Now x into x square is x cube, then minus 2 into x is minus 2x. Okay, so write it below the x term only, minus 2x. Now change signs. Wherever plus is there, do plus. Wherever plus is there, make it minus. Wherever minus is there, make it plus. Okay, now plus 3x and minus 3x will get cancelled, 0. Now here you can see, so here there is nothing, I'll take 0. Here also I'll take 0. Now 3x square plus 0 is minus 3x square plus 0 is minus 3x square. Now 5 plus 2x square is 7x square. Minus 3 plus 0 is minus 3. Now again you can see, if I multiply the divisor by minus 3, okay, minus 3 into x square is minus 3x square. The first term is getting cancelled. So and now 3 into 2 is 6, minus into minus is plus, so I'll write here. So wherever below the x term, write the x term only. Below the x term, write the x term only. Like that you keep on writing. Below the constant term, you write the constant term. Okay, now here change the sign. Now here it is nothing, it is 0 here. Now this will get cancelled. I'll get 7x, minus into minus is plus, so plus 9 I'll get. Now I can't do division further, because now the degree of the remainder is lesser than the degree of the divisor. Okay, here I should stop the division. So this is the remainder, okay, and this is the quotient. Here it is minus 9. Okay, second sub question. So p of x is equal to x power of 4 minus 3x square plus 4x plus 5, and g of x is x square plus 1 minus x. Now g of x, I'll reorder it. I can write as x square minus x plus 1. Okay, in the descending order of the power of x I am writing. Okay, now divide x power of 4 minus 3x power of 2 plus 4x plus 5 divided by x square minus x plus 1. So if I take x square, the first term will get cancelled. X into x is x power of 4. So x square into x is 3. X power of 3. Okay. So minus x power of 3. Then x square into 1 is plus x square. Okay, here I'll write 0. So I'll change this sign. Okay, so these two will get cancelled. Now here you should be very careful. You should do addition or subtraction with this. Okay, there's no x power of 3 term in the above. Okay, so I'll get x power of 3 as it is. X power of 3 as it is. Now minus x square minus x square minus x square is minus 3x square minus x square is minus 4x square. Now plus there's one more x term there, 4x as it is plus 5. So should be very careful. Now next, if I multiply by x, then x into x is x cube, then x into x is x square, x into x is x square, and x into 1 is x. So here I'll write 0. So change this sign. So these two will get cancelled. Minus 4x plus x square is minus 3x square. So minus 3x square here, plus 4x minus x is plus 3x plus 5 as it is. Now if I multiply by minus 3, I'll get minus 3 into x square is minus 3x square. Then x into minus 3, minus x into minus 3 is plus 3x. Then minus 1 into plus 1 into minus 3 is minus 3. Now change the sign. Minus becomes plus, plus becomes minus, minus becomes plus. These two will get cancelled, and here also these two is getting cancelled. I'll get 5 plus 3 is plus 8. So now there completes the division. This is the remainder and this is the quotient. Exercise 9.3, question number 1, sub question 3. The given equations are the given polynomials are x power of 4 minus 5x plus 6 and 2 minus x square. So now 2 minus x square, and I can write as minus x square plus 2. First the x terms and then the constant term. So now x power of 4 minus 5x plus 6 divided by minus x square plus 2. Now I should multiply such that the first term should get cancelled. So I should make the first term equal so that I can cancel. So minus x square into minus x square becomes plus x power of 4. Now I can cancel these two. Now plus 2x into minus x square is minus 2x square. So here I'll write 0. So minus plus, okay, these two I can cancel. Now you should be very careful. You should add or subtract only the like terms. Unlike terms you can't do. So here 2x square remains as it is plus 2x square, then minus 5x remains as it is, then plus 6. Okay, now if I multiply by 2 minus 2, okay, minus 2 into minus x square is plus 2x square, then minus 2 into plus 2 is minus 4. So minus 4 here. So here I'll write just 0. Now change the sign, minus here plus. So these two will get cancelled, and minus 5x as it is. Then 6 plus 4 is 10. Now you can see the degree of the remainder. The degree of the remainder is lesser than the degree of the divisor. So at this point I'll stop the division. This is the quotient. So as long as the degree of the remainder is higher than the degree of the quotient, I can go on. As long as the degree of the remainder is higher than the degree of the divisor, I can continue division. Once the degree of the remainder is lesser than the degree of the divisor, then we should stop division. So here the degree of remainder is 1. So minus x power of 1 plus 10 is there. So degree is 1. In the divisor you can see the degree is 2. So now I'll stop the division. Exercise 9.3, question number 2. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. So if it is a factor, it is perfectly divisible. Okay, 2t to the power of 4 plus 3t square minus 2t square minus 9t minus 12. I should divide by t square and check. If it is divisible, then remainder I'll get 0. So let us check it. So to make the first term equal, I'll multiply by 2t square. So 2t square into t square is 2t to the power of 4. Then here 3 into minus 3 into 2t square is 2 3s are 6t square. Okay, plus minus 6t square. I'll write under the like terms only. Now here I'll just put zeros. Now change the sign, minus plus. Okay, below 0 it doesn't matter. Now plus 2t square minus 2t square will get cancelled. Now I'll get 3t cube. So sorry, this is t cube. Okay, so 3t cube. Then minus 2t square plus 6t square is plus 4t square. Then 9t as it is, minus 12. Now if I multiply by 3 plus 3t, I will get 3t into t square is 3t cube. Then minus 3 into plus 3t is 3 3s are 9t. So I'll get minus 9t. Okay, here I'll put just 0, here also I'll put 0. So now I'll change the sign. So wherever 0 is there, it doesn't matter to change. So these two will get cancelled. Plus 3t cube minus 3t cube will get cancelled. Now I'll get 4t square. Then plus 90 minus 90 also will get cancelled. So 4t square minus here minus 12 plus 0 is minus 12 only. Now if I multiply by plus 4 into t square is 4t square. Then 3 4s are 12 minus 12. So I'll get 0. So it's divisible. So what was the question? Check whether the first one is a factor. Yes. T square minus 3 is a factor of 2t power of 4 plus 3t square minus 2t square minus 90 minus 12. Exercise 9.3, question number 2, sub question 2. So the given equation are 3x power of 4 plus 5x power of 3 minus 7x square plus 2x plus 2. So this I should divide with x square plus 3x plus 1 and check whether it is divisible or not. So to make first term 0, first term equal, I will multiply by 3x square. So 3x square into x square is 3x power of 4. Then 3 3s are 9, 9x cube plus 9x cube. Then 3 into 1 is 3. So plus 3x square. And now change the sign. These two will get cancelled. Plus 5x cube minus 9x cube is, I'll get minus 4x cube, because 9 is greater than 5, that's why minus sign there. Now minus 7x square minus 3x square is minus 10x square. So 2x plus 2 as it is. I could have written 0 also there. Okay, now if I multiply by minus 4 into x, okay, x square into minus 4 into x is minus 4 x power of x cube. Then minus x into plus 3x, 3 4s are 12, minus into minus, minus into plus is minus, so 12 x square. Then minus 4x into 1 is minus 4x only. So change the sign. So these two will get cancelled. Minus 4x cube plus 4x cube. Then minus 10x square plus 12x square is 2x square. Then here 2 plus 4 is 6x square, 6x plus 2. Now if I multiply by 2, the first term will get equal, will become equal. So 2 into 2, 2x square. Then 2 3s are 6x plus 2 1s are 2. So not only the first term, all term are coming equal. Now I cancel everything, so 0. Therefore it is factor. X square plus 3x is plus 1 is a factor of 3x power of 4 plus 5x cube minus 7x square plus 2x plus 2. So x square plus 3x plus 1 is a factor. Exercise 9.3, question number 2, sub question 3, x cube minus 3x plus 1 and x power of 5 minus 4x power of 3 plus x square plus 3x plus 1. So x power of 5 minus 4x cube plus x square plus 3x plus 1. I should check whether x cube minus 3x plus 1 is a factor of this. So now I'll divide. So to make first term equal, I'll multiply by. So this is x power of 5. Okay. So I'll multiply by x square. So x cube into x square is x power of 5. Then 3x into x. 3x into x is minus 3. X power of x into x square is x cube plus 1 into x square is x square. Now change the sign, minus plus minus, these two will get cancelled. So plus 4x cube minus 3x cube is minus 1x cube, minus 1x cube. So here these also are getting cancelled. I'll be left with plus 3x plus 1 also is there. So I could have put zeros here also. Now if I multiply by minus 1, what will I get? I can make the first term equal. So minus 1 into x cube is minus x cube. So minus 1 into 3x is plus 3x. So minus 1 into minus 1 is plus 1. Sorry, minus 1 into plus 1 is minus 1. So minus 1 I'll get. So now change the sign. I should change sign everywhere. At one place I'll change sign and another place I won't change. That's not possible. So minus x cube plus x cube will get cancelled. Plus 3x minus 3x will get cancelled. But here 1 plus 1 I'll get 2. Now I can't divide further. So 2 means it's actually 2 power of 2 into x power of 0. Okay. Now what is the degree of x here? Degree of x is 0. And what is the degree of divisor? The highest degree. It is 3. X power of 3 is there. So since the degree of remainder is less than the degree of the divisor, I can't divide further. Okay. So 2 into x power of 0 is 2 only. This is 2. And this is the remainder. And this is the quotient. And x cube minus 3x plus 1 is not a factor of x power of 5 minus 4x power of 3 plus x square plus 3x plus 1. Okay. If it is a factor, it would divide perfectly and the remainder will be 0. Here remainder is not 0, so it's not a factor. Exercise 9.3, question number 3. Obtain all the zeros of 3x power of 4 plus 6x power of 3 minus 2x square minus 10x minus 5 if two of its zeros are square root of 5 by 3 and minus square root of 5 by 3. So square root of 5 by 3 and minus square root of 5 by 3 are the two of its zeros. So square root of 5 by 3 is a 0. Therefore x minus square root of 5 by 3 is a factor of the given polynomial. Similarly, square root of 5 by minus of square root of 5 by 3 is a 0. Okay, therefore x minus of minus square root of 5 by 3 is a factor. So this turns out to be x plus square root of 5 by 3. Okay, now I'll multiply these two factors. Okay, multiply the factors x minus square root of 5 by 3 into x plus square root of 5 by 3. So now this is in the form of a plus b into a minus b. So this is equal to a square minus b square. So this is equal to now x square minus square root of 5 by 3 the whole square. So this is equal to x square minus square root of square root of 5 by 3 is 5 by 3 only. Okay, now I'll divide the given equation by this. So similar problem is there in solved exercise problem. Once you can check it out. So the given polynomial is 3x power of 4 plus 6x power of 3 minus 2x square minus 10x minus 5. I'll divide this by x square minus 5 by 3. Now to make the first term equal, I'll multiply by 3x square. 3x square into x square is 3x power of 4. Then 5 by 3 into 3x square. So x square, so 3 will get cancelled. I'll get 5. So minus 5 by 3 into 3x square is minus 5x square. So here I'll put zeros. So now change the sign and add it. So these two will get cancelled. Now plus 6x cube I'll get here. Then here minus 2x square plus 5x square is plus 3x square plus 10x plus 0 is minus 10x plus 0 is minus 10x minus 5. Now again 6x cube is there, so I'll multiply by x plus 6x. Okay, if I multiply by 6x into x square is 6x cube. Then 6x into 5 by 3 minus 5 by 3 is 3 1s are 3, 3 2s are 6, 2 5s are 10. 10x I'll get minus 10x. So here I'll put 0, here I'll put 0. Now change the sign, minus here plus. So below 0 there's no need to change, it doesn't matter. So these two will get cancelled, these two will get cancelled. Now I'll get 3x square minus 5. Now if I multiply by 3, what will I get? Plus 3. 3 into x square is 3x square. Then minus 5 by 3 into 3. So 3 will get cancelled. I'll get minus 5. Okay. So here 0, here 0. Okay, it is divisible. That means 3x square plus 6x is also a factor of the given polynomial. Therefore 3x square plus 6x plus 3 is also, so 3x plus 6x plus 3, what is this? This is the quotient. So quotient is also a factor of the given polynomial. Now if I factorize this quotient, I'll get another 2 zeros. So now I'll equate the polynomial 3x square plus 6x plus 3, this I will equate to 0. Why I should equate to 0 is to find the zeros. So now I'll take 3 common here. So x square plus 3 2s are 6, 2x plus 1 is equal to 0. Now 3. So x square, I'll split the middle term. I can write as plus x plus x. So x plus x is 2x and x into x is x square. So first term is x square, last term is 1. So I'll get x square. So middle term, if I multiply, I should get x square. So x into x is x square. I'm getting okay, plus 1 is equal to 0. So now this is 3 into, here I'll take x common, x into x plus 1 plus 1 I'll take common here, x plus 1 I'll get, this is equal to 0. So 3 into, now here x plus 1 into x plus 1. So I'll remove the square brackets. 3 into x plus 1 into x plus 1 is equal to 0. So therefore x plus, so this the above is 0 when x plus 1 is equal to 0 or x plus 1 is equal to 0 or x is equal to, if I bring minus 1 plus 1 to the right hand side, I'll get 1. X is equal to minus 1. Here also I'll get x is equal to minus 1. So minus 1 and minus 1 are the roots or zeros. Zeros and roots are the same. Okay, I'll write that also. Minus 1 and minus 1 are the roots of the given polynomial. Which is the polynomial 3x power of 4 plus 6x cube minus 2x square minus 10x minus 5. So the problem completes here. So one more line I will write just for your understanding. So 3x power of 4 plus 6x cube minus 2x square minus 10x minus 5. This was the given polynomial. So this is equal to, two zeros were known, root of 5 by 3 and minus root of 5 by 3. Therefore this is x minus root of 5 by 3 is a factor of the polynomial and x plus root of 5 by 3 is a polynomial. And also we came to know that this is also a factor, that is 3x square plus 6x plus 3. So now this I can write as x minus square root of 5 by 3 into x plus square root of 5 by 3. Now 3x square plus 6x plus 3 also we factorized. What was that? It is 3 into x plus 1 into 3 into x plus 1. So the given polynomial can be expressed as the product of factors. Okay, so x minus square root of 5 by 3 into x plus square root of 5 by 3 into 3 into x plus 1 into x plus 1. So altogether there are 4 factors and there are 4 zeros. Which are those 4 zeros? This is 1 0 minus square root of 5 by 3 and this plus square root of 5 by 3, this is 1 0 and minus 1 is another root and minus 1 is another root. So altogether 4 zeros are there for this given polynomial. The last 3 lines, these are not necessary, just for your understanding I am telling you. Exercise 9.3, question number 4. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and the remainder were x minus 2 and minus 2x plus 1 respectively. Find g of x. So the meaning of this sentence is x cube minus 3x square plus x plus 2. So if we divide this polynomial by g of x, okay, if we divide, ultimately we get remainder as quotient as x minus 2 and remainder as minus 2x plus 4. That's the meaning of that sentence. Now I should find g of x. Now what is divisor? Okay, divisor is equal to dividend. Okay, dividend is equal to divisor into quotient plus remainder, right? So dividend, what is dividend? Here we know that dividend is x cube minus 3x square plus x plus 2. So what is divisor? Divisor is g of x. What is the quotient? Quotient is x minus 2, and what is the remainder? Remainder is minus 2x plus 4 is the remainder. Okay, now I'll bring the remainder to the left hand side. Okay, bring the remainder to the left hand side. So x cube minus 3x square plus x minus 2. If I bring the plus 2, so if I bring the remainder to the left hand side, minus 2x becomes plus 2x plus 4 becomes minus 4. So this is equal to g of x into x minus 2. So now this is x cube minus 3x square. Now plus x and plus 2x, I'll get plus 3x. Then plus 2 and minus 4, I'll get minus 2. So this is equal to g of x into x by x minus 2. Now I'll bring this x minus 2 to the left hand side. If I bring, what will I get? It will come to the denominator. So x cube minus 3x square plus 3x minus 2 by x minus 2 is equal to g of x. So we want to find g of x only. That's the question. Find g of x. Now if we divide this numerator by denominator, we'll get the answer. Let us proceed. So x cube minus 3x square plus 3x minus 2. So divide by x minus 2. To make the first term equal, I'll multiply by x square. So x square into x is x cube. Then x square into minus 2 x square, I'll get minus 2 x square. So change the sign, minus here plus. Now these two will get cancelled. Minus x square plus 2x square, I'll get minus 2, 3 minus 2 is 1. So minus 1 x square. Okay, then here 0, here 0. So plus 3x minus 2. Now what can I do? I'll multiply by minus x. So minus x into plus x is minus x square. Then minus x into 2, minus 2x, plus 2x I'll get, plus 2x. Now change the sign. Everywhere I need to change. Plus becomes minus, minus becomes plus. So plus 1x minus 1x will get cancelled here. So plus 3x minus 2x is plus 1x. Okay, plus 1x here minus 2. Now if I multiply by 1, I can perfectly divide. So plus 1 into x is x, 1 into minus 2 is minus 2. So change the sign. So this 2 will get cancelled, I will get 0. So g of x is nothing but x square minus x plus 1. So g of x is equal to x square minus x plus 1. That completes this problem. Exercise 9.3, question number 5. Give examples of polynomials p of x, g of x, q of x and r of x which satisfy the given algorithm, and degree of p of x is equal to degree of q of x. Okay, now take one simple example. 3x plus 6. What is 3x plus 6? It's a linear polynomial. So now if I divide this by 3, so what will I get? So now in the numerator I can take 3 as common, x plus 2. So 3 will get cancelled. I will get x plus 2 only. Now 3x plus 6 is nothing but p of x. Okay, and x plus 2 is nothing but remainder. Okay, q of x. Now you can see in both p of x and q of x the degree is same. The highest power of x is 1. Okay, and now I'll give another example, and 3 is here is nothing but g of x. Okay, g of x. Now I'll give another example. 2x square plus 4x plus 6 by 2. Now here if I take 2 as common in the numerator, 2x, so I'll get x square plus 2x plus 2 3s are 6. Okay, so this will get cancelled. I'll be getting x square plus 2x plus 3. So now numerator here I'll consider as p of x. So x square plus 2 plus 3 will be equal to q of x. Okay, quotient, and 2 will be g of x. Now here also you can see p of x, the degree of p of x is equal to the degree of quotient q of x. Okay, now second example, second sub question. So give example such that the degree of quotient is equal to degree of remainder. Okay, now for this I'll give this example. P of x is equal to x cube plus x square plus x plus 1, and g of x I'll take x square minus 1. There are so many examples actually, so this is very easy to remember, that's why I am giving you. Now if we divide, you can check it out. X cube plus x square plus x plus 1. If I divide by x square minus 1, so x into x is x cube, then minus 1 into x is minus x. So I'll put 0 here, I'll put 0 here, change the sign. Now these two will get cancelled. I'll get x square plus 2x plus 1. Now again if I multiply by 1, so 1 into x square is x square, then 1 into minus 1 is minus 1. Now change the sign, I'll put 0 here, change the signs, so I'll get 2x plus 2. So this is nothing but remainder or of x, and this is nothing but quotient. X plus 1 is nothing but quotient, and x square minus 1 is the divisor. Okay, now here you can see the degree of quotient is equal to the degree of remainder. In both the case the highest degree is 1. Okay, so not only this, in exercise 9.1 question number 1 and in question number 2 you can check some problems or like this only, where you get the degree of quotient and remainder to be same. Now third sub question. So here degree of remainder should be equal to 0. Now what is a cubic polynomial, or what is a linear polynomial? Linear polynomial is given by p of x is equal to ax plus b. Suppose if a is 1 and b is 0, then we get p of x is equal to x only. Similarly, quadratic polynomial is ax square plus bx plus c. If a is 1, b and c are 0, we get x square as the quadratic polynomial. Now I'll divide quadratic polynomial by a linear polynomial. So what will I get? So x into x is x square. So I'll get 0. Okay. So remainder is 0. Remainder is 0 means even the degree of the remainder is 0. So here dividend is x square, divisor is x, and quotient is x. Now similarly, if I divide a cubic polynomial by a quadratic polynomial, so x square into x is x cube. So remainder I'll get 0. So when remainder is 0, the degree of the remainder also is 0. So not only that, you can find some examples in exercise 9.3 in question 1 and question 2. There are some examples wherein you get the remainder 0. So these examples are very easy to remember. That's why I have given. Exercise 9.4 is optional. These problems will not come to examination. You can try by yourself. I'll be skipping it. Now summary of this chapter. Polynomials of degrees 1, 2 and 3 are called linear, quadratic and cubic polynomials respectively. So you can see if the highest power of the variable is 1, then it is linear. If the highest power of the variable is 2, it is quadratic polynomial. If it is 3, highest power of the variable is 3, then it is cubic polynomial. And a quadratic polynomial in which in x with real coefficients is in the form of ax square plus bx plus c, where a, b, c are real numbers with a is not equal to 0. So this you know, the zeros of a polynomial p of x are precisely the x coordinates of the points where the graph of y is equal to p of x intersect the x axis. So you can see here linear polynomial when plotted, it will intersect x axis at one point, and that point is nothing but the 0 of that linear polynomial. So it is denoted by alpha. A quadratic polynomial, it may intersect x axis at 2 points, say alpha and beta. Not necessary it always intersects at 2 points. Sometimes it may intersect at 1 point, and sometimes it may not intersect at all. And in cubic polynomial, it may intersect at 3 points, and let us say it's those 3 points are alpha, beta and gamma. So here also not necessary always it will intersect at 3 points. Sometimes it may intersect at 2 points, sometimes it may intersect at only 1 point. So in the fourth point they have mentioned, fourth and fifth point, a quadratic polynomial can have at most 2 zeros and a cubical polynomial can have at most 3 zeros. So in the graph only you can check it out. Sometimes if sometimes quadratic polynomial may not intersect x-axis at all, and sometimes it may just touch x-axis at 1 point. Okay, so overall a quadratic equation may have 2 zeros maximum, and a cubic polynomial can have at the most 3 zeros. That means it can intersect x-axis at the most at 3 places. Okay. Next, if alpha beta are the zeros of the quadratic polynomials ax square plus bx plus c, then alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. Similarly, if alpha beta gamma are the zeros of the cubic polynomials ax cube plus bx square plus cx plus d, then alpha beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. And last, the division algorithm of any polynomial p of x is given by p of x is equal to g of x into q of x plus r of x. Okay, and where q of x is the quotient and r of x is the remainder and g of x is the divisor, and the degree of r of x is always lesser than degree of g of x. And that completes this chapter.